morning. So myself, Thomas. I am from Digital Core Technologies, Kochi. So my company is basically into the electronics system design services. That's the domain we work. That's a portfolio. About 20% of our resources and revenue we invest in in-house R&D. It's actually a startup started 11 years back, and MSME from micro, we have grown to small now. So that is where we are. And over the last couple of years of our in-house R&D investment, we could develop a fully indigenous thermal imaging core. So today my talk will be mostly on, I'll be sharing about that. So that is the title given, Vision to Vigilance, the indigenous thermal core. And just about from my experience of working in this domain, the importance of indigenization value addition for that. So please feel free to ask questions if any. This is our office in Kochi. We have early office in Kochi. So when we talk about vision, actually what comes to us, basically the organ which we all have, which is probably one of the most important organ in my mother tongue. There is a saying that your mother and your eye, these two values we'll know only when we lose it. So that is the value which it tells about that. And if you see the key factors about human vision, about 80% of what human gather is through the visual interaction. About 1/3 of our cerebral cortex is analyzing visual world. 90% of the information transmitted to the brain is visual information. So visuals are processed 600 times faster than any other inputs. So overall, if you see, we depend a lot on our vision. And when it comes to surveillance and defense, this is probably one of the most dependable sensing which we have. And vision also have got another definition. It is seeing what is not visible to others, vision from a other perspective. So actually when it comes to our what we can directly see, actually technology helps us to see what beyond what we can see, especially in defense, starting with radar. This is one of the major supporting system through which we see beyond what we can see. The way it presents the information is slightly different, because not in the normal video way. We have to interpret from that. Of course, there is a lot of useful information from there. Whereas when it comes to the sea, water, of course, radio waves cannot transmit. So the only alternative or the other option of that is sonar. Similar to the presentation is same again. We'll know some object is at what distance and some amount of size, speed, etc., but not a direct visual thing. So when it comes to thermal imaging, it is that way much better. We get a clear equivalent vision of what we otherwise see. So that is where the thermal vision helps to see things. Of course, in water, that's not possible. Only sonar works in water. But in air, this is very useful. So how does it work? When just to look at the science behind it, as we all know, it's all based on the electromagnetic energy spectrum available in the environment. So out of that, the so-called rainbow color range, the spectrum, violet to red, is what our human eyes are sensitive to. That comes about 0.4 micro, the wavelength of, from the physics, if you see the wavelength of the wave from 0.3 micrometer to 0.7 micrometer is what is our human eyes are sensitive to. And below violet we call it as ultraviolet, and after red we call it as infrared. So this is our eyes depends largely on this. The thermal infrared actually is somewhere in the far infrared range. Actually, infrared is divided into multiple bands. near infrared, short wave infrared, and medium wave and long wave. Out of this, actually, thermal comes to the medium wave and long wave. That is basically any object at a temperature more than minus 273 degree, the absolute zero, radiates energy as a heat wave, and that is the thermal IR. So this is what we make use in our thermal vision. There is only one animal known to have the thermal vision, that is pit viper, one of the snakes family. In addition to the normal eye, it has got a pit below the eye. Through that, it can see infrared and it can bite on the veins by seeing the warm blood path. So that is what actually if you see the wavelength, the 3 micrometer to 14 micrometer is what the thermal infrared. Out of that, 3 to 7 is the medium wave and 7 to 14 is the long wave. Basically, I am just referring. So this is the bandwidth wise, if you see. Actually, there are cameras sensitive to short wave infrared also. And the visible band and near infrared, if you see, every digital cameras, even our mobile phones or any CMOS cameras are sensitive to near infrared. Many CCTV cameras, they say night vision that is based on the near infrared. But that cannot see beyond some point, it's only nearby areas. Again, using the electromagnetic waves in the ambient. Now, this category up to shortwave IR, the cameras depend on energy reflected from the object. Now, the way we see. Now, the light falls on you and when it reflects and falls on my eye, I see you. Whereas the thermal infrared, as I said, two of them, why I say cooled and uncooled is based on the detector sensor technology. So, the sensor used to sense medium wave IR, they are all cooled detectors because the sensor itself is maintained at minus 273 degree for a better sensitivity. So when we need to get a long range view, we use cooled one, which depends on the medium wave, whereas the uncooled ones depend on the long wave IR, which is, that sensor is also working on the ambient temperature. Both of them works on the radiated energy mode. Actually, it is not reflected, it radiates from the body. So basically, you don't need any other source. We need light to see in the VIBGYOR because that works on the reflected light, reflected energy. Whereas thermal one does not need any other source. We ourselves, the target itself is the source. So that is the advantage there. So that way, we saw the fear mostly comes from darkness. So IR helps us to get rid of that fear. If we can see in dark, that is what the confidence infrared gives. So typical image sample if you take in a camera, this is the spectrums if you can see. Of course, I have given the visible band, I have given a monochrome image. Basically, the color is nothing but again a further split of wavelength within that. So that is the rightmost two things are the medium wave and long wave IR. You can see the clarity is more for medium wave IR. Just give an idea of this. This short wave IR is also used by defense, especially it gives a better visibility in the marine environment. That is one of the reasons why SWIR is used. The long wave and medium wave IR, another advantage is you can see through the fog also. Not only darkness, even fog we can see through. There is another device, gadget being used, it's normally called a passive infrared or it is image intensifier. This is also used as a night vision, but the difference is that the image intensifier works again on the light only, not by the heat. So you should have at least little bit of light. Let's say at least starlit night. So there is a comparison of what it does is it's a picture tube wherein it is photonically multiplied. The whatever small little light available is multiplied and that is how it is used. So if you see the greenish color, that is how you see in an image intensifier or a passive infrared. Very difficult to differentiate a human in the scene. Whereas in the thermal infrared, we can very easily differentiate a human in the scene. So comparatively, it gives much more better visibility and differentiation of the target. So this is another comparison between passive infrared and the thermal camera. And the passive infrared has got another disadvantage. You should not open its lens in when more light is there, because the life of the tube depends upon how much light it falls on that one. So that should not be. Whereas in the thermal cameras, you can use in day and night. There is no difference in its life. So a sample video I have just to see how. I hope it. This is how it looks in the complete. Left side is taken from a mobile camera. It's completely dark. Right side is taken using the thermal camera. So even in a little bit of trees and canopy, you can see because of the heat. So that's the advantage we get through IR vision. This is similarly another video. This is, of course, inside a room only, so temperature control, so you get a better clarity. This is a remote controlled weapon. So another advantage, like you can have a thermal camera put on your weapon, a weapon sight having a Wi-Fi transmission. So from remote, you can control the weapon station and even trigger it. Actually, we have made a prototype of this. The trigger part is getting worked on, and once that is ready, we will be able to demonstrate that, which can work from a maybe from a bunker. You can see the scene as well as shoot safely by safeguarding the person there. Now, this is just a few background information. Then coming to the building blocks of that, when we say about the indigenization, actually, I believe that as I understand today, the percentage of indigenous content is computed just based on the price of material. You take whatever is imported and what is the sold price. If I have support, maintenance, and maybe the profit together 20%, that means 20% indigenization. That is one limitation I see there, whereas if you look at the value of the building blocks, if you consider, give a weightage for that, then that becomes more meaningful indigenization is what I believe in. So from that perspective, if you see the building blocks of a thermal imaging camera, the most important two parts are the thermal core. We call thermal core. That is what which converts the sensor output into a digital frame. Then comes the use case dependent electronics and software. For example, if a thermal sight, weapon sight, that is the one which manages the sight, the reticles, we can do the zeroing of the reticle, the user interface. Similarly, if it's a long range surveillance camera, this pan, tilt, zoom controls, video streaming. So these are all depending upon the use case, whereas the core will be common for all these applications. Core will have different for cooled and uncooled, but otherwise it is common. Then, of course, the mechanical and optics. Mechanical for like any product, the mechanical has to be strong and environmental resilient. Comes to the optics. The thermal optics is also special. It is basically glass does not allow heat pass through. So if you see through a glass, you don't see anything in a thermal camera. So it has to, the germanium-based lenses are used. That's another today material challenge also there. However, from my understanding, these leftmost two things are the most operational critical, plus that is the vulnerable part of the product. Because if you depend on an imported thermal camera, the core hardware software and the functional hardware software, they are the most critical ones. Cost, if you take component cost of this, the most highest cost items are the thermal detector and the lens. Unfortunately, both of them, there is no Indian manufacturer, no company who can sell in India. So if I just take the BOM cost, that itself takes more than 50% of the cost. But the value-wise, if you see, actually the value comes for the electronics, hardware, and software. The components does not make a product. Product is made by the circuit and the software. And components we can get from different sources. But electronics we cannot mix with the different sources. That way, my feeling is that we should give more weightage to the actual intelligent content of that indigenization, then it becomes more valuable. So that is the context I just wanted to put it here. So please feel free, any questions are there. Now when you say core, the thermal imaging core, physically this is a core which we have developed in-house. This is used in all, this is an uncooled one, this is not cooled one. We have cooled one also developing, we are just in the final stages of that. So this is what the sensor which we get from, actually we get sensor from Linred, France. There are only 5 companies who has got thermal detector. In fact, our one of the DRDO lab, SSPL, is working on that for years, and we are also looking forward. Once the SSPL lab has a sensor, now since we have the complete indigenous core, we can easily integrate it, add to that one. Similarly, we are working with another Indian company in Hyderabad. He is developing a thermal sense lens, which is not germanium, a new material, startup company. So once they have the lens, we can add to that also. So we believe in more of complementing and building the systems. We have expertise in electronics and this core. Others, if we can work together, we can definitely make a 100% indigenous system tomorrow. So this is one of the main part of the thermal camera, thermal core. If we just get whatever signal comes from the sensor, it just looks like this only. So there is a image pipeline. There's an FPGA program which runs inside that one, which makes this possible, makes it as a visible video. Over that you can put the graphics overlay, and most of the places you see a thermal image, you see a color encoded one, just a color palette addition. So all these features happens in the thermal. This is what we say core. So just to have a comparison of this thermal, the long wave and medium wave, as well as the cooled and uncooled IR band and the optics lens. Actually, this is what differentiates for different use cases. So what is our requirement and what should we choose for that? So lens broadly we can take material wise, of course, germanium and silicon. Germanium is used mostly for the cooled and uncooled, whereas silicon is used for one of them. Motorized zoom and fixed zoom. Because why I'm saying this is that's the 2 components which consumes more than 50% of the cost is lens and the detector. So the lens, it's a thermal zoomed lens, cost can go up to even 20 lakhs depending upon the range it can cover. One of the camera which we did for Atlantic defense, a 150 mm motorized lens, we could detect a aircraft from 50 kilometers that is using uncooled camera. That is because, of course, the aircraft has got a very high temperature compared to the ambient. That lens itself cost about 16 lakhs rupees. So there we had to choose based on our need, and the main factor is a DRI, detection, recognition, identification specification, which we call. The size, of course, the size, field of view, cost, weight, all this comes into picture. Similarly, LWIR, MWIR. The LWIR or uncooled one, low cost, small size, low power, lightweight. So typically, for example, all thermal weapon sights, small weapon sights all use uncooled one, small size, low power battery. Whereas when you need longer range of visibility, then you can go for medium wave IR. So these 2 differences which we have. And there is some confusion I see when we get the specification from defense on the DRI specification. Actually, there is no clear defined objective specification, slightly subjective, but there is a criteria which internationally being people use it, even because we started working with a European company for their thermal products, and that is where we got into this domain. So the Johnson criteria is one of the criteria which they use. As per that, the detection is a range where the smaller dimension of the object falls on at least 1.5 pixels, and recognition is which goes on the 4.5 pixels. So a detection range, if it is 900 meter, a recognition should be 1/3 of that. But most of the time I see the spec half of that. So that is just one point I wanted to mention. Because time I think is less, I just work a bit quickly. We have a booth here, so anybody has got any questions, any discussions, feel free to visit that. So thermal weapon sight is one of the largest volume-wise consuming of thermal core I have seen, thermal camera. We have supplied already to a couple of customers this the core, and it is used in the thermal weapon sight also. This is just a video where a testing of the site is given. So in the dark, pitch dark night, we can see the target. This is just a small thermal pad put on the target, so that's very clear in the night. So thermal weapon sight, if you see, these are similar to what I shown earlier, the block diagrams. So weapon sight has got mechanical, has to be very stable, it has to withstand all the weapon firing, backfiring force, shock. So these are the aspects we have to take care of. And of course the accessories required for that. So this is a new one which we are developing. This is a cooled camera with a pan tilt, gyro-stabilized pan tilt platform. So this is getting ready by, actually we will be having a demo ready by January. So this gives much more clarity, much more visibility, longer range also. You can see there are two water tanks. The water level, you can see the dark part is where water is there. And above that it is, because the temperature difference, it is a temperature difference which goes there. So since time is less, we have given name Mantis for this one. That's the camera view. Specification of lens, just to give a glimpse of that. But any lens we can integrate. This is the sample which we have taken first. So with the cooled, you can see a human we can detect from about, human from about 10 kilometers and then, human 6 kilometers and vehicle about 20 kilometers in pitch dark. So this is same platform. If you use uncooled one and zoom lens, we can use then up to 5-6 kilometers. We can get the ranges. So depending upon the purpose, we can select the items. So one of the use case which we proposing, I mean, this is not ready. Once our Mantis is ready, what we plan is to develop another cooled, uncooled one, multiple cameras. So it's basically to give a 360-degree surveillance, multiple small low-cost cameras to give short range, and the one pan-tilt platform which can go to any specific location, zoom in and view things. So this kind of a platform we can propose so that we can display the whole surround view, and wherever we need, we can control and go and zoom in for far distance. So this is just an example, but what we would look forward is basically discuss with the users and find out the actual requirements and customize. When we have this option, we can customize. Otherwise, we get import from outside and then we 100% depend on them, even for maintenance or any feature additions. So this is where we look forward for associating. And this is some more, this is a driver night sight which we have. This is actually this camera, 3 of them we have installed in INS Vidyut as a early fire warning system. This thermal camera has got another advantage. We can measure the temperature of every pixel, so it can be used to even monitor the temperature variations. So I'll just conclude it with this one. So ultimately, every pixel counts. Every pixel, a properly done product, every pixel can save a life. So, but when those pixels come from indigenous technology or outside. So it's not a choice, it should be a necessity. So with that, I would conclude my talk, and please feel free to come and discuss if any questions are there.